So let's look at this example. Want to evaluate a double integral where the region R is given by these inequalities. So let's look at what it is. X squared plus y squared less than or equal to 4. What does that mean? It means things inside the circle of radius 2. So that's the entire disk. This is x squared plus y squared less than or equal to 4. Okay? But we also want x to be non-negative and y to be non-negative. So what does that mean? That means we only want to look at the part where both x and y are positive, and that tells us it's only this quarter of disk. Okay, so our region of R is only the disk in the first quadrant. Let me redo it. So this is the region R. Okay. Then of course I can say, okay, so then this line is, let's say, like, for example, y equal to square root of 4 minus x squared. Then I say, oh, then using the Fubini's theorem, the y direction for any fixed x value, y direction has lower limit 0, upper limit to this line. So then I have 0 to square root of 4 minus x squared, x plus y, and this is the limit for y, so then dy. Then what is all the possible x value? So that'll be anything from 0 to 2. So this is one way we can do it, but we can kind of see it looks complicated. So let's try polar coordinates. So polar coordinates, how do we describe this region R? So this will be theta from 0 to a half pi. And what is the R? R would be anything from 0 to R equal to 2, right? Oops, 0 to 2. So you can see that if I use polar coordinates, the region R can be described very easily. It does not involve a function, does not involve square root, it's just the constants. So now the integral under polar coordinates, the dA is turned into R, dr, d theta. The bounds for R is 0 to 2. The bounds for theta is 0 to a half pi. X is R cosine theta. Y is R sine theta. Remember, use parentheses. Okay? So then I'm gonna have to distribute the R into these two terms. So this is 0 to a half pi, 0 to 2, R squared cosine theta plus R squared sine theta, and then dr d theta. Okay? Okay, so then the rest is just straightforward computation. I will let you finish. Okay, so for example, if you wanna take care of the R first, then antiderivative here will be 1/3 R cubed. That's a factor because they have R squared is the common factor, so just do it all together. Right? And R is from 0 to 2. Right? So this gives me 8/3 cosine theta plus sine theta. Okay, so this is the result from the first layer, and then you use this for the second layer. Okay, so it should be very straightforward.